All right, set 7 is multi-step factoring. Now, this is where it really gets interesting because here we're going to be, again, the instructions are still factor completely. Factor each of the following as much as possible. And so it's really going to be important that we pay attention to every single little detail as we're doing this. All right, so let's look at the first one. The first thing I note is that, oh my gosh, this is next to the third power. Now, we've done stuff like that before, so it's not too big of a concern, but this will turn out a little bit different. So let's go ahead and look at these. We're going to say, all right, first thing I should look for in any factoring situation is, very good, the common factor. So I look at 16, 24, and 16. And I know that 8 goes into each of those. And then I also notice that an x goes into each of those. So I'm going to put the 8x, and then we're going to write down what's left. So 16 divided by 8 is 2. X cubed divided by x is x squared. Now we go on to the next one. Negative 24 divided by x is minus 3. X squared divided by x is x. And then negative 16x divided by 8 would be negative 2. All right, so that's nice and lovely. But now I have to look at what's left because the question asks us to factor as much as possible or factor completely, which means I now need to look at what's left and say, can I factor this further? Now, my first question is there still a common factor? Is there something that I missed? And I don't see anything else common to those three terms inside the parentheses. The 8x, I can't factor that anymore. That's done, so I'm just going to leave it there. But the stuff inside, can I change it? And, well, it is a trinomial, so we should try to factor it further. So the 8x is still in front, but now I'm going to try to factor the stuff inside the parentheses up there. So what times what will give me 2x squared? Well, 2x and x. It's a negative here, so to multiply to get a negative, I'm going to have a plus and a minus. So I'm just going to guess at their positions. I may need to change that later. I may need to put the minus over here and the plus over here, but for now, that's just what we'll try. And then what two numbers multiply together to give me a negative 2? Well, really, it's positive 1 and negative 2, or negative 1 and positive 2. And so let's just try 1 and 2. And of course, we're going to check it because that's how we make sure that we've done it right. 2 times negative 2 is negative 4x. 1 times x is plus 1x. And it just so happens that those add together to give me negative 3x, which is what it was supposed to give me. And so therefore, I will box this as my final answer. So yes, there are three pieces. There's an 8x, a 2x plus 1, and an x minus 2. And that's that. Let's go ahead and look at number 2. All right, first thing we do is... Yes, I'm waiting for you to answer the question. That's right. Take out the greatest common factor. So we look at 16 and 64. We say what goes into both of those? Well, I know the 8 goes into both of those. Now, before you say, Mr. Bauer, you're such a silly man, I understand that there's another number that's bigger. But I just want to show you that this still works if you don't pick out the biggest number right away. Now, we also notice that an x comes out. Okay, so let's take out that common factor. 16 divided by 8 is 2. X cubed divided by x is x squared. And then I've got a negative 64, which divided by x, negative 64 divided by 8 is minus 8. And then x divided by x cancels out. Now, I've done that, so I'm going to look at this again. And if I look at this again, I say, see, I got another 2. I could have taken another 2 out. So what we need to do is pull that 2 out as well, which means I'm going to have an 8x in front, but then I also am going to take out another 2. So if I take out another 2, I've got x squared minus 4. And so now I say, okay, I've taken out everything that's common. I divided both of those by 2. I can put the 8x times 2 together to give me 16x. But then at this point, I'm looking at the x squared minus 4. And I say, okay, can I factor this further? It's not a normal trinomial, but it still is a quadratic. And so if I can do something about that, I will. Now, hopefully, you recognize that this is a difference of two terms. And so we should look at whether this is the difference of squares. The first term is something squared. Is the second term? Why, yes, it is, Mr. Bauer. It's 2 squared. And so with that, it's an a squared minus b squared, which means I can write it as a plus b. Let's go back to my black. A minus b. Now, if you wanted to check this, of course, you could distribute and FOIL, or FOIL and then distribute, and it should take you back to the original. But this is the correct complete factoring because I can't factor it any further. Nothing else comes out of any of these pieces. They're all fairly simple, and so that's where we're going to go on to number 3. Next couple I'm going to go through a little bit faster, so let's see if we can get through those. Okay, 48x squared minus 27. Is there anything common? Well, I know, let's see, what goes into 27? Well, 27 is 27 and 1. 27 doesn't go into 48. And 3 and 9. Oh, 3. Does 3 go into 48? Why, yes, it does. So let's factor out a 3. Now, if I divide 4 by 3, I get 1 with a remainder of 1. So I've got 18. 3 into 18 is 6. X squared minus 27 divided by 3 is 9. And so at this point, I took out the 3. I don't see anything else common here. So let's see if we can now factor this. Well, it does look like I've got here a 4 squared, and then an x squared, and then a 3 squared. Now, since it's the difference of two things that are squares, we can now rewrite this. Keep the 3 in front. But then the stuff inside is going to be a, right? Because this part, the 4x is the a, and the 3 is the b. So 4x minus 3, plus 3, and 4x minus 3. You're right. It doesn't matter which one is first, the plus or the minus. So there you go. That is correctly factored. There's nothing else. There's no more common factors. I can't break those up any further. That's it. Let's go on to number 4. Number 4, let's look for a common factor first. 4. If I divide that by 4, I get x squared. If I divide 48 by 4, I get minus 12x. And if I divide 36 by 4, I get plus 9. All right, so at this point, we're going to try to factor further. Can I factor this any further? Well, hopefully you recognize that no matter what I do, right, if I put the x and the x, two numbers that multiply together give me 9. Well, 1 and 9 or 3 and 3, and neither one of those, when I put it in these spots, is going to allow me to add up together to give negative 12x. So since neither of those work, then I'm just going to finish it right here and say that the stuff inside is prime, and this would then be considered completely factored. Now, if it was equal to 0, you could still solve for that because we have the quadratic formula that allows us to solve for an equation, right? We can use the quadratic formula to solve for any equation. And so just because it's not factorable doesn't mean it's not solvable. Now, if this were equal to 0, I would then pull out my quadratic formula, and I would put in 1 for A, negative 12 for B, and 9 for C, and I would work it out. Okay, let's go on. We got 2 more that we need to do for this. So let's go to number 5. Number 5 for this set is going to be 8x squared plus 24x plus 16. All right, so let's try to factor this first. Is there a common factor? Well, yes, Mr. Ballwater, there's an 8. So let's take out the 8, which will leave me with x squared. 24 divided by 8 is plus 3x. 16 divided by 8, so plus 2. All right, so now let's see if we can factor this any further. There's no more common terms in there. So x times x is x. What time? Oh, plus and plus, so that means these have got to be positive. And so what times what gives you 2? Well, 2 and 1. And let's just double check it. X times 1 is 1x. 2 times x is plus 2x. and I put those together and I get 3x, which is what I was looking for. Remember, this is the thing I'm factoring now. And so once I have that, this would be my final answer. Sorry. Okay, let's go on to the last one, numero 6. Won't quite finish in 10 minutes, but that's okay. That's life. So number 6, let's go 3x squared minus 3x minus 60. So this one's meant to be a little bit easier after all the other ones we've done. Let's take out the common factor first. So 3. And so now I've got x squared minus x minus 20. And so then we try to factor the trinomial, because we always look and say, can I factor this further? And yes, you can factor this further. X times x is x squared. It's a minus, which means I'm going to need a positive and a negative. And now I need to figure out what two numbers multiply together to give me 20. So I've got 1 and 20. I've got 2 and 10. I've got 4 and 5. The most promising one to me looks like 4 and 5. So let's try the 4 and 5 and check it to make sure we got our signs right and everything. So negative 5x, negative 5 times x, and then 4 times x. Negative 5 plus 4 is negative 1x, which is what it's supposed to be. And so therefore, this is correctly factored. All right, there you go. Move along.